In today's lesson, we are going to use the vocabulary that we've learned to help us solve problems with angles. As a quick review, supplementary angles add up to 180. Complementary angles always add up to 90 because a complement is the right thing to say. So, and a right angle is 90 degrees. That's an easy way to remember that. Adjacent angles are just next door neighbor angles. They share a side and a vertex or a point, so they are next to each other. Vertical angles are always opposite and equal. So x is opposite of y, so the degrees angle or the measure of x would equal the measure of angle y. All right, make sure you have the practice problems in front of you so you can solve them along with me. It should be called Angle Practice 1 Ed Puzzle. All right, problem 1. It says the angles are complementary. And complementary angles, I know, add up to how many degrees? 90 degrees. So if they say they're complementary, we don't even have to see the little box here. That means these angles add up to 90 degrees. So if I know one angle, then I can figure out the other by just taking 90 degrees, subtracting 48, and getting the missing angle. So 90 minus 48 equals, if you did this on your calculator, 42. So our answer would be 42 degrees. Of course, another way we could set it up as an algebra problem, x plus 48 has to equal 90. So x plus 48 would have to equal 90 right here. So we could solve by subtracting 48 from both sides. Subtract 48, and that goes away, of course. So now we have x equals 90 minus 48 is 42. So the missing angle is 42 degrees. All right, problem 2. Well, I'm looking at the problem. I've got an angle x and an angle that's 112 degrees, and I see that they form a straight line. And we know that a straight angle, if we're just looking at this, is 180 degrees, so halfway around a circle. So we know that x plus 112 would need to equal 180 degrees. And it also tells me the angles are supplementary. But even if it didn't say that, we would see they are because they form a straight line if you add them together. All right, so we know supplementary angles, we know they're going to have to add up to 180 degrees. That's one thing I definitely know. So if I know they add up to 180, then the missing piece is easy to find. I can just take 180 minus 112 degrees and find my missing angle. So I'm going to go ahead and do that. All right, and we see that the missing angle is 68 degrees. So x would be 68 degrees because 68 plus 112 is 180. Of course, another way we could do that is just write an algebraic equation. So x plus 112 would have to equal 180. Subtract 112 from each side. That goes away, and x does equal 68. Oops, 68 degrees. All right, problem 3. Let's look at these angles for a moment. So we have one that we see as 70, and the others we don't know. All right, so let's fill in the blanks. Supplementary angles equal, I think you know now, 180 degrees because they form a straight line. And vertical angles are equal. Oh, this is very sloppy. Equal, oops, that's a Q. Equal and opposite. They're always opposite each other. All right. So let's use those definitions to help us solve this problem. So we need to find out angles A, B, and C, what their measures are. And I'm going to first do the easy thing that I see. I'm going to use my knowledge of vertical angles to find out what B is, because I know that B is opposite the one we know. So if this angle is 70 degrees, then I know this angle is equal to that. So I'm going to put here that angle B is also 70 degrees. And I'm going to write that in here. oops, very sloppy. All right, so now I know those two angles. So now I'm going to look to solve what angle A is. All right, so one thing I want you to notice is that this is a straight line. So if that's a straight line, then this angle, this angle, and this angle, they would add up to 180 degrees, right? So you can kind of look at it sideways a little bit. So this angle, the 70 degrees plus A, would have to equal 180 degrees. Well, we know part of it, so we know the 70, so 70 plus A would have to equal 180. So I can just do a subtraction problem. 180 minus 70, and that would give me my missing angle A. So I know that would be 110 degrees. So A is 110 degrees. All right, so I'm going to write that in. So 110. Now I'm going to use my knowledge of vertical angles again to solve angle C. Well, if A is 110, well, C is opposite that. So I know that C would have to equal 110 also. And I've solved all my missing pieces. I don't know if you can, well, you can see. I'm at a soccer game. Corey is number 74, and they're getting ready to play. So I'll maybe show you some video of the game. All right, now look at problem 4. And the first thing I want to do is practice naming angles, or practice looking at angles and knowing which one they would match to. So look at angle ABC, and trace that angle with your finger. The middle letter is always where the vertex is, or where the point is of the middle of the angle. All right, so ABC is ABC. So it's referring to this angle here. Oops. All right, so angle Angle CBD refers to CBD here. All right, angle DBC, start with D, DBC, referring to this opening here. All right, angle ABE, find ABE, so it refers to the 50-degree angle right here. An angle EBD, find E, and trace it, EBD. So it refers to this opening here. And last, angle DBE. So this angle could be, so this is DBE, or you could name it EBD. So either way you want to name it is fine. All right. Question 4A, which angle is adjacent to angle ABE? So that's this 50-degree angle. Well, let's talk about adjacent angles first. They are next door neighbors. So if angle X, if we're talking about angle X, which angles are adjacent to angle X? Angle Z, because that's right next door. They share a side and a vertex. And angle Y, right here, because angle Y shares a side and a vertex with angle X. Angle W is not adjacent, it's across, it's opposite, so that would be a vertical angle. All right, so which angle is adjacent to ABE? Again, this one's ABE, so adjacent. So here are our choices. Is it CBD? So I'm going to trace it D. CBD is this one, CBD. Or is it EBD? EBD. So which one is adjacent? Well, adjacent angles share a side and a vertex, and this is the one, this is ABE here. So which one's next door? EBD. So you would choose that one right here. That is the correct answer. All right, next question, which angle is vertical to angle ABE? Well, remember vertical angles are opposite and they're equal. So angle ABE is here, and we know this one is opposite, and that's named CBD or DBC. So let's see, ABC is not vertical, so it's not that one. DBE is this one. So CBD. So this one is CBD, and that one is opposite, so it is that angle. And angle CBD would be equal to 50 degrees, since it's a vertical angle. All right, now let's finish problem 4 and do C, D, and E. So C, what is the measure of angle CBD? Well, angle CBD is this angle right here, and I see that it is across from or opposite of ABE, and ABE is 50, so these two are vertical angles. Vertical angles are equal and opposite, so I know that CBD is 50 degrees also. So let me try to write that in there really small. All right, so now D. What is the measure of CBA? So CBA, trace that with your finger, CBA, so that's this measure right in here. Well, I see that this, here's the clue, this is a line, and if I look at this angle, which is 50, and this angle, ABC, well, they're actually supplementary angles because they make a straight line, so ABC and ABE would add up to 180. So if we know one, we can figure out the other. So one's 50, so 180 minus 50 would be 130. So this angle would be 130 degrees. All right, last question. Last question, what is the measure of angle EBD? So let's trace that one, EBD. So EBD is a vertical angle of ABC. They're opposite or across from each other. So that one would be 130 degrees also. So, and that's it. Oh, one thing I did want to point out is this angle, angle CBA, I could have called this angle ABC also. So CBA is the same as angle ABC. It doesn't matter which side you start from when you're naming it. All right, now we're going to focus on triangles. So this is on the back side of the page. Question 5. So it says, remember the sum of the interior angles of a triangle equal how many degrees? So the interior angles are the inside angles, and there are 3 of them, and they always add up to 180 degrees. All right, question 6. So we need to look at this triangle and solve for x. So we know one angle is x plus 2. One angle is 40, and I see this little square, which means this must be a right angle, which is 90 degrees. I'm going to write that in. So that one's 90. So now we need to solve for x, but if I know 2 of the angles, I can figure out what this measurement should be. So all the angles need to add up to 180. So 90 plus 40, so far we have 130 degrees because 90 plus 40 is 130, but we need to them to add up to 180 degrees. So 130 or 180 minus 130 would give us our missing piece. So our missing angle that we don't know right here, x plus 2, equals 50 degrees. So now we can solve the problem. So I can say x plus 2 equals 50 and solve for x. So I am going to get x all alone, subtract 2 from both sides. So x equals 48. So the measure of x is 48. So if we plug that back in to our missing angle, 48 is x, so x plus 2 is 50, and that's what we decided that angle would have to be. So we solved for x, and it was 48 degrees. Question 7, we're going to solve the same way. We are looking at the triangle. We know the 3 angles of the triangle have to add up to 180. We have 2 of the angles, so 60 plus 70, if I added those, if you can use your calculator, I would have 130 degrees. So, because 60 and 70 is 130, so I know that the missing angle has to be 180 minus 130. So again, that one's 50 degrees also. So 3x plus 5 has to equal 50 degrees. Or that angle has to equal 50. So now we can solve it using algebra. So I'm going to say that 3x plus 5 equals 50. All right, and I'm going to continue to solve. I need to get the x terminal alone so I can subtract 5 from both sides. I want to get that to become 0. All right, so now I can bring my 3x down. 3x equals 45. And then I need to turn whatever's with the variable into 1, so I can divide 3 by 3. Do that to the other side. So x equals 45 divided by 3 is 15. So let's plug that in and see if that works, because that angle, the missing angle, needs to add up to 50 degrees. So if we plugged 15 in for x, 3 times 15 is 45, and 45 plus 5 is indeed 50 degrees. All right, problem 8, last problem. So we need to solve for x. So I see a triangle with one missing angle. We have 40 and 55, and those, if we could figure out what those equal, then we know that all of them have to add up to 180. So 40 plus 55, so far we have 95. And we know all 3 angles would have to add up to 180. So what is left for this angle? Let's subtract. So 180 minus 95 would leave us with 85. So we know that this angle has to be 85 degrees, because 85 plus 55 plus 40 would equal 180 degrees. All right, so now we can solve it using algebra. We can set 2x plus 3 equal to 85. So let's do that. So 2x plus 3 equals 85 degrees. Now we're going to locate the variable term. We need to turn positive 3 into 0, so negative 3 to both sides. Bring down my equal sign. That goes away. So 2x equals 85 minus 3, which is 82. Now to turn the whatever's with x into 1, I would divide by 2, and now I have x equals 41. So we just solved for x. So x is 41. Let's make sure we got that right. So 2x plus 3 needs to equal 85 degrees. So we're going to plug 41 in for x. So let's see, 2 times 41, well, that would be 82. And then 82 plus 3 is 85. So we know we did our problem right. And that is it. All right, here's one clip of the game. That's Corey. It's Corey? Yeah, it wasn't a very exciting game. It actually was a 0-0 tie, but it was a nice day to watch soccer.